From a young age, we're mesmerized by their colors, flight patterns, and the wonder of how they originate and emerge from a chrysalis. As we look closely at butterflies, few people realize they create a deep challenge for the theories of undirected evolution and just how strongly the evidence points to a purposeful designer. Coming up on today's edition of Origins, the butterfly enigma with Dr. Paul Nelson. Hello and welcome to Origins. I'm Ray Heipel. It's an honor to be your host today. During this program, we showcase interesting guests who present evidence from science along with other important facts validating the truth of creation and the accuracy of the Bible. Our guest today, Dr. Paul Nelson, studied evolutionary theory and the philosophy of science at the University of Chicago. He's currently a senior fellow of the Discovery Institute and adjunct professor in science and religion at Biola University. Paul has been involved in the intelligent design debate internationally for more than 2 decades. Paul, welcome to the show.
Hey, it's great to be here.
We're going to be talking about butterflies today. I think I know something about butterflies, but what is the enigma?
In a nutshell, or in a chrysalis, it's how do you go from a caterpillar to this kind of creature? This is a female monarch. The males have on either side of the abdomen little dark patches right about here and there where they store pheromones, cologne, okay, for mating purposes. This creature is remarkably different than its earlier form, which is a caterpillar, yellow and black striped. How do you go from that way of living to this way of living and maintain viability and explain that by an undirected evolutionary process?
Well, that would be a trick to show that.
That is a puzzle. Before we get there, though, let's step back and ask, what is the main responsibility of a scientist? Really, when you come to look at a puzzle in nature, what's your main job? Well, we need to look at the natural world in such a way that all of the possible explanations are on the table for consideration. We shouldn't rule any of them out before the evidence has a chance to speak for itself.
Science is supposed to go where the facts go, right?
Exactly. It's meant to be an open-ended search for the truth. In fact, Elliot Sober, who is a philosopher of science at the University of Wisconsin and a friend of mine, he's a critic of intelligent design, but he taught me something very important about this question. When I was a student, actually an undergraduate, I read one of his essays where he said, saying what the cause is like knowing where the treasure is buried. And I think he's right about that. Determining the cause in science, let's say of a disease or of some puzzle in geology that you don't understand, learning the cause is really like finding the treasure. In fact, that suggests a helpful metaphor. Imagine that we are on a desert island, right? And we want to find the treasure, okay? And the treasure is down here at the southern tip. Here we are with our shovel in hand. We don't want to put this treasure out of reach. That's what the dotted line indicates here. You can't go down there and dig. Because if in science that's where the true explanation lies, we want to be able to get there and not rule it out beforehand. The problem is if we do that, we do rule it out, we're going to dig fruitlessly on the rest of the island. And the truth will be out of reach. So it's very important for science to be open to all the causal possibilities. And the one we're going to look at today is, might it be true that the butterfly and the caterpillar came to be not by undirected natural processes, but by intelligence?
Well, that seems fair. If we're going to really go where the facts push us to go, then we shouldn't rule out the possibility of an intelligent creator.
That's right. We need to be able to keep the whole island open for exploration. So, before we get there, let's look at the leading evolutionary explanation for how that butterfly metamorphosis evolved. And it's the theory of natural selection. Natural selection has 3 essential premises. They all have to be present for the process to occur. First, you have to have variation, differences. So look at the two of us. I mean, your hair color is different than mine. We both have brown eyes, but I'm a lot chunkier than you are, right?
We both don't have a lot of hair.
No, it's going away rapidly, sad to say. But just within Homo sapiens, our species, we see all kinds of differences. Every species on the planet exhibits differences. And if those differences make a difference to the number of offspring you have, right, more or less, and you can transmit them, those differences, to your offspring, then natural selection will occur. And this is a real process. We have lots of examples of it, in fact. The question is, can this process explain that butterfly metamorphosis transformation? Here's a good way to remember how natural selection operates. You've got a three-legged stool. Variation, selection, heredity, natural selection will occur. As I said, it's a real process. The question is, can this process explain that key transformation in butterflies? So, one other aspect is important before we look at the butterflies in details, and that is what needs to be explained when we're talking about animal evolution. Now, Francis Crick was a scientific hero of mine. He won the Nobel Prize for co-discovering the molecular structure of DNA, but he was well known as a gadfly. So he would meet people in the Salk Institute, for instance, where he worked for the last part of his career, and buttonhole them. Literally sort of, poke them in the chest and say, I'll tell you why you can't solve your problem. You're too dumb. Here's how the problem should be described, and here's how you solve it. So Gabriel Dover, the author of this passage, was a geneticist who went to work with Crick on the problem of macroevolution in the early 1980s. And Crick told him, he said, look, you're never going to solve the problem of evolution until you understand how organisms are put together. Now, what does he mean by that? Well, here's what he means. This is a complex system, a very complex system, but it's built by a developmental process. That is, you start, most animals, not all, but most animals start their existence as a single cell, a fertilized egg. So in humans, it takes 9 months to go from that single cell to an 8-pound baby, right? Well, a developmental process also exists here. So what Crick is saying is, if you want to understand how to change living things, you've got to understand how they're built. So here's a little cartoon that kind of brings the point home. Let's suppose we want to transform A into B. And I realize that real organisms are more interesting than colored squares and pentagons and PowerPoint, but this would be a macroevolutionary transition, to go from a 4-sided figure to a 5-sided figure. Well, if A is an animal, A is going to be built by a developmental process that starts with a single cell, the fertilized egg. Then there's a developmental trajectory with cells dividing and differentiating that gets you over here to the adult. So if you want to transform A into something that looks like B, you've got to change the construction process. Just the way that if you had an automobile factory and you wanted to go, let's say, from a regular internal combustion engine to a Wankel rotary engine, or you wanted to go from 2 axles to 3 axles, you would have to modify the construction process that gets you over to your completed vehicle. So that's what Crick means. You want to understand this evolutionary transition, you've got to change this, the developmental pathways. All right, now, let's look at the problem of metamorphosis. This can't happen. There's no dying in evolution. No crying in baseball, no dying in evolution, right? If this is the evolutionary transition that you want to explain, and you've got to add stages to a developmental process like this to get over there, you can't pass through a stage where you're temporarily dead, even for a moment. That can't happen. So keep that in mind, because when we come back to the butterflies, this will be critical. All right. Animal development, building something like a butterfly, is very complicated. In fact, I've compared it to a magic bridge. So here is a chasm, let's say in Southern California or maybe in Hawaii. And the magic bridge of animal development is magic in the following sense. We start over here on this side, and we're walking across, and as long as we keep walking, the bridge will be there beneath our feet. If we stop or look over the side or turn around and go back, the bridge disappears. So that would be right at home in any Indiana Jones movie, right? Keep moving, the bridge will be there. Now, why is this a puzzle for evolution? Well, in animal development, reproductive capability is over here on the far side. Remember, being able to reproduce is a necessary condition for natural selection. So how did natural selection build this bridge, put it in place, when one of its necessary conditions is over here on the far side? This is a puzzle for evolution that has never been able to solve. Development, going from a single cell to an adult creature that's capable of reproduction, means crossing a long magic bridge where you can't stop. Once that single cell begins to divide, it's got to get all the way over here, eventually to the point where it can reproduce. So, let's go back to our 3 requirements of natural selection. If you can't do this, if you can't reproduce, you don't have your functional stool. You don't have natural selection. Bottom line, if you can't leave viable offspring, you're invisible to the evolutionary process. Now, I'm showing you this slide now so it doesn't seem really weird when I show it to you later, okay? I'm just sort of breaking you in. This is Houdini here, suspended by his feet. Here are 3 of his assistants. He's being lowered into a water box, right? And he's going to escape. Let me ask you, what's the one thing he won't let himself do in this situation? The box is really full of water.
Well, he has to stay alive the whole time he's in the box.
He's got to stay alive, so he's not going to go in unless what?
He's got some kind of plan.
He's got some kind of plan to get out, and probably a backup plan in case the main one fails, right? Mm-hmm. So a wise magician like Houdini is not going to let himself go into that box unless he knows how he's going to get out. All right, keep that in mind when we come back to butterfly development. All right, here are now much more interesting than colored squares, real insects. Here again is our female monarch. And when you look at monarch biology, the monarch life cycle, it's fairly complicated. Here's our starting point. This is the egg that will hatch into the caterpillar, and this is basically an eating machine. It goes through 5 molts. I don't know if you remember the movie Bug's Life, going to be a beautiful butterfly, right?
Yes, I remember.
He's eating all the time. So in a monarch, the caterpillar will increase its weight 3,000 times from here to its final molt. That's a huge gain of mass. And it's important because when it gets to the chrysalis stage, much of the mass of this caterpillar is going to be turned into structures that have no counterpart from the caterpillar present here in the adult. It's a dramatic transformation. Same DNA, but a very different kind of way of living, okay? Here's some details. If you go in a forest preserve and find some milkweed, lift up a leaf, and if you see that, that is a monarch egg. The female deposits the egg on the underside of the leaf, and she's very careful to place them far enough apart that they have enough vegetation to eat. Here's a close-up view. Looks like kind of like a little dome. Beautiful structure. So at this point, the caterpillar has gone through its molts, and it's ready to form the chrysalis. What it does is it attaches itself to a little silk pad that it spins and places on the underside of a twig, inserts its cremaster like natural Velcro into that silk pad, and then this is the stage of real mystery. In fact, here is where the evolutionary puzzle really is the deepest and most significant.
Well, hold that thought, Paul. We need to take a break. Stay with us. When we come back, we're going to show you what happens that turns a caterpillar into a butterfly. You're not going to want to miss this. Welcome back to Origins. We're talking to Dr. Paul Nelson, who's been sharing some fascinating things about butterflies. Paul, we left our, well, not yet butterfly friend trapped in this chrysalis. How's he going to get out of there?
Now that is a world-class question, because what's going on inside here is just amazing. This is a 7 to 10 day interval in the life of any butterfly. What's happening inside here during that interval is the caterpillar is really being digested away. the chrysalis is attached to a little silk pad by a structure called the cremaster on the end of the chrysalis there. And if you zoom in on it, you'll see it's like natural Velcro. So notice these little hooks here? Mm-hmm. They are embedded in silk strands up there in the silk pad that the caterpillar has woven, actually. But let's zoom in even closer. Here's an engineering question for you. Why have these hooks if you don't have the silk pad? But why have the silk pad if you don't have the hooks? So you can see that there is a complicated integrated relationship here where you need both major elements to have any function at all. Very characteristic of biology, that kind of complexity.
So both have to be there at the same time, or one of them would have just as worthless.
It wouldn't work. It wouldn't work. So anyway, you asked what's going on. Well, what's going on is the caterpillar is being digested away by carefully regulated processes of cell death where the cells are literally committing suicide. In fact, it's really so remarkable. We've got a nice video clip to show that helps us understand this. It comes from a movie that I worked on called Metamorphosis from Illustra Media. And I think it's really interesting. So we should take a look.
The creation of a butterfly begins with the partial destruction of the caterpillar. Inside the chrysalis, larval cells that form the caterpillar's limbs and organs are systematically digested and broken down.
You've got to get rid of or digest the caterpillar tissues. They won't work for the adult. In fact, the cells themselves disappear, but then their components are recycled and are turned into a kind of soup out of which the adult structures will be built.
Throughout this process, the imaginal cells, the foundation of the adult insect's body, are preserved to differentiate and multiply.
Now, cell death is programmed. It's not something that happens by accident. If you kill the wrong cells, you're in deep trouble.
It's very carefully engineered. You're going to save some of the cell populations, so you got to know where you're going to end up before you start. You don't want to digest everything, just things that need to be eliminated. Then the imaginal discs rapidly begin to proliferate, and you can trace a continuous pathway into the pattern on the wing. Now, here's the puzzle. You're digesting away, literally eating up or getting rid of your previous way of life. You're going into a very different adult form. We can see part of it here. This is a sort of pictorial representation of the end of the metamorphosis process where the exterior wall of the chrysalis begins to thin and you can begin to make out the form of the adult butterfly there. In fact, when it comes out of the chrysalis, it's got more construction to do. So I don't know how well you can see it, but right here, it is knitting together its proboscis, the feeding tube that it will use throughout its adult life. And when the proboscis initially comes out, it's two halves, like this, right? Well, half a straw is not a straw. You can't suck up any nectar with half a straw. So it unrolls and rolls up, unrolls and rolls up this structure, putting these two halves together to make that feeding tube. And it's building its wings. So these veins are hollow, and from its abdomen, it pumps fluid through these dark veins to extend the wings out. They can dry and then become genuine flight surfaces. So this isn't the end of the story. There's still more construction to do to make a functioning adult butterfly.
About how long after it comes out of the cocoon does it still working on creating
It takes
parts?
a couple hours, and it's a critical stage. In fact, the butterfly has to be able to stand free and not touch anything because these flight surfaces are extending out and drying and becoming true wings. Now, before the break, we talked about Houdini. Let me go back to him. Explain why he's in this show. Here he is, being lowered by his feet, three of his assistants looking on. You said he's not going to go in unless he knows how to get out. And we all know why. The alternative is death. I mean, there's really water in there, right? So let's look at Houdini. He's not going in without a plan to get out. The same thing is true of the chrysalis. Think about it from an evolutionary standpoint. You evolve to the stage where you can form a chrysalis and digest away most of your caterpillar tissues. And that's all you have. That's the full extent of your plan. This is not a viable endpoint, right? You're done.
That's a coffin.
That's a coffin. That's not a chrysalis, that's a coffin. You need to know, how am I going to get out of here over to that adult butterfly? Evolution, by definition, Darwinian evolution, is an undirected process. It doesn't know where it's going. It's relying on random errors in genetic material. And to solve this puzzle, evolution would need to have something like foresight or planning, which it doesn't. There's no mind on the scene, no intelligence.
So otherwise, a caterpillar on, generation number 4,812 just decides to build this chrysalis and crawl inside of it.
And turn to goo.
And turn to goo.
It's not going to happen. It's not going to happen unless you know how to get out. In fact, this is the very kind of structure that evolution would never predict, because it requires that plan to get out. And the only kind of cause we know that can do that is a cause that can see a distant endpoint.
Well, and the caterpillar itself is already a viable creature. Why would it need to do anything else?
Why would it bother? It seems like a lot of trouble to go through, right? So remember, I showed you before the break this slide. This can't happen. If your evolutionary story requires you to go through a stage where, for all intents and purposes, you're dead, this could not have been the pathway by which butterflies came to be. And I would say to Darwin, if he were here with us today, Charles, this looks to me like disconfirming evidence for your hypothesis. The general problem for evolution is development is a complex pathway. So here's a little hypothetical organism, just 5 cells in the adult. No animal is that simple, but it's a cartoon after all, right? To get over here, from our starting point, the fertilized egg, over to the adult, we've got to put all these stages in place. But they don't have any permanence, as it were. You've got to cross that magic bridge. It's here, let's say, where reproductive capability is. So how did natural selection construct all of that when one of its necessary conditions is over here? As I said earlier, this puzzle has never been solved by evolution. Natural selection as a process only sees function and reproductive output. It can't build this kind of a bridge. That's a problem for the theory. So I think the way to think about this is, how do organisms get the instructions today? They have parents. Mom and dad put the information in place to build the monarch life cycle. If you want a butterfly at all, you need the whole story.
So once you have a butterfly, the answer is pretty easy. The butterfly mates with another butterfly. They lay eggs. The egg becomes a caterpillar, eventually builds a chrysalis, comes out a butterfly. But if you don't have that,
you're not going to get it. You're not going to get this unless you already have it. And again, the only kind of cause we know that can do that can aim at a distant functional target, reuse modules, establish discontinuities where the system is first, none of its parts, the system as a whole is first. Those kinds of requirements, the only thing we know that can do that is this. And you know what? That's science. That is good, solid science. And there's no reason we shouldn't be able to say this in science. To say, look, the evidence from butterfly metamorphosis clearly indicates a cause that could see where it was going.
If that's the way things work in really anything else, you take a carpenter, you take an architect, they always start with the blueprint. They look at the last phase, what we're going to do. They have that plan, and then everything else is geared towards that.
That's right.
It seems like the same thing here with the butterfly. There's got to be information.
There's got to be information, and it's the concept, it's the idea that comes first. That is then actualized. So if we go back to our island, I want science to be able to get down here if the evidence indicates it. If this is where the truth is, science should be free to pursue that. Really, I think butterflies and other creatures that go through this kind of complex metamorphosis are a clear signal from nature about her author, about her original and primary source.
And if intelligence really is indicated by the truth and by the evidence, then a true scientist, just wanting to know and put together the puzzle, is going to go there.
That's where they're going to go. And they'll have the courage to do that and the courage to defend it as a bona fide scientific conclusion.
What do evolutionists say as far as the caterpillar turning into the butterfly? Do they have any answers at all?
Well, the problem is this kind of puzzle is not really explained by an undirected process, and all current evolutionary theories rely strictly on natural law and chance. Mind is not allowed. So this puzzle is currently unsolved, and I expect it to remain unsolved.
Well, I really thank you for that information, and I hope you appreciated learning these things. According to evolution, a caterpillar must turn into a butterfly only with the mechanisms of mutation and time, random mutations in time. And we've seen that the evidence itself says there has to be information, there has to be a direction, there has to be intelligence, which means there has to be a mind. And that's good news for those of us who believe what the Scripture says, that God created all things, that He created them according to His purpose, His will, His mind. Well, we know what the Bible says is true, and the proof is all around you. Thanks for joining us for this edition of Origins. We'll see you next time.
Thank you for watching this edition of Origins. For a DVD of this series, you can order online or send a $12 donation to cover shipping and handling. And write to Origins Program, number 1801, Cornerstone Network, Wall, Pennsylvania, 15148.
This presentation was made possible by the faithful prayers and financial support of you, our Cornerstone family.